we're going to do a series circuit. A series circuit is one where there are two or more resistors in the circuit, and they're all following one after the other, so they make one loop from one side of the battery to the other. In this example, we're going to have a potential difference of 24 volts, that's its voltage, 3 resistors, one with 30 ohms resistance, one with 16 ohms resistance, and our third one with 50 ohms resistance. The first thing we need to do is find the total resistance of the entire circuit. One of the properties of a series circuit is that the total resistance, or equivalent resistance, is simply the sum of all the resistors. So for this case, total resistance would be 30 plus 16 plus 50, which is 96 ohms. So that's our total resistance. Usually after we find the total resistance, we want to find the total current. To find the total current, we're going to use Ohm's law. Ohm's law is voltage or potential difference equals current times resistance. So V equals IR. So our total voltage is 24 volts. Current we don't know. And resistance is 96 ohms. Put little t's to represent total so I know what I'm working towards. So in this case, we're simply going to take 24 divided by 96. We do that. 24 divided by 96. We get 0.25 amps of current. Another property of a series circuit is that the current is the same every place, because there's only one route from one side of the battery to the other, so the current has to go through each object in turn. And so, according to Ben's Franklin definition of current, which is the flow of positive charge, current leaves this side of the battery and goes through each one. Now, everything comes on at the exact same time. It's not where this comes on first, then that one, then that one. Everything comes on at the same time, because as charges enter the circuit, it causes the charges that's already in the circuit to shift over at the exact same moment. So everything comes on at the exact same time. We're going to figure out the current in each thing. And since the current on a series circuit is the same every place, every object is going to get 0.25 amps. So 0.25 amps through that one, 0.25 amps through that one, 0.25 amps on the last one. Now what will change in a series circuit is what we call the voltage drops. How much voltage each object gets from the battery. And so, for the first one, we're still going to use Ohm's law, but now we're going to individualize it and just talk about resistor number 1. So V equals IR. So we're just going to talk about the first resistor. We're actually looking for voltage, so we don't know what it is, but we know the current is 0.25 amps, and the resistance is 30 ohms. So to figure out the total voltage drop for that one, simply take 0.25 times 30, and we get 7.5 volts. That's how much of the voltage from the battery this one gets to use. For the next one, for resistor 2, we're going to do the same process, except this time use just the numbers for resistor 2. It still gets 0.25 amps, and its resistance is 16 ohms. So again, if we take 0.25 times 16, we get 4 volts for this one. For the last one, we repeat that process. You do this for every resistor that you have in the circuit. So if you've got 5 resistors, you're going to do this 5 times. V3 equals I3R3. Current is still 0.25. Resistance is 50 ohms. So if we do that calculation again, 0.25 times 50, we get 12.5 volts. Now the really nice thing about a series circuit is that you can check your answer. An easy way to check your answer is simply add up the voltage drops for each individual resistor. We got 12.5 volts, 4 volts, and 7.5 volts. So if we add those up, we get a total of 24 volts, which is the same voltage as our battery. And if you do that, or if it's pretty close, depending on if you have to round things off, you should feel very confident about your answer. So if your voltage drops added up individually, it adds up to the total voltage from the battery, you've done well. The last thing we need to do is calculate power. Now power will be how bright or how loud that resistor is functioning. So if it's a speaker, it's how loud it is. Well, each resistor here has a different resistance. So which one is the brightest if these were light bulbs? Well, we can figure that out by figuring out the power for each one. Now, first I want to figure out the total power of my entire circuit. So power is current times voltage. So P equals IV. So in this case, our current is 0.25. And our total voltage, again we're dealing with totals, is 24 volts. And so, if we take 0.25 times 24, we get 6, in this case, watts of power. So this circuit generates 6 watts of power in total. Individually, we have to see how that works out. So we're going to use the power equation again for each individual resistor. So power for the first one equals the current through the first one times its voltage drop. So everyone gets 0.25 amps. Voltage is 7.5. And so if we figure out the power for it, 0.25 times 7.5, we get a power of 1. Let's call it 8.8. It's actually 1.875, but I'll round it up just for this example to keep to 2 decimal places. We're going to do this again for each resistor. Current again, 0.25. Voltage drop for this one is 4. So we do this one, we get 1 watt of power given off by that second resistor. The third resistor almost made a mistake. We're going to do the same process. So for that one, if we take 0.25 times 12.5, we get 3.125. I'm going to go ahead and say 3.13, just for this example. Now if we add those up, the numbers that I put up here, 3.13 plus 1 plus 1.88, we get a total power of 6.01 watts. Well, that's very close to what we got here of a total of 6 watts. So if you add up the individual powers, it should equal the total power. The reason why we're off by that one little bit is because I rounded off to 2 decimal places. If I kept all 3, we would have got exactly 6 watts. So that's how you do a series circuit. Thank you. Tune in again, we'll do a parallel circuit.